Section 2.6, Foundations of Math 10. We're working out of Pearson Foundations and Pre-Cal Math 10 textbook there. And in 2.6, the title is Applying the Trigonometric Ratios. So we've learned about tan, we've learned about sine, and we learned about cos. And we've done some application problems of each. It's easy to find some kind of angle between, between two points. An angle measure. We can also find missing side values or side lengths of a triangle. And so this is a bit of a summary here, and also I want to introduce what solving a triangle means, okay? Up to this point, when I say solve for x, or solve for the angle, or solve for something, there's one thing in particular we're looking for. When you see or hear the phrase solve the triangle, or solving a triangle, that means to find all of the angles and all of the sides of the triangle. So it means all three angles and all three side lengths, okay? So we'll be solving triangles, and we'll have to use a combination of sine, cos, and tan to do that. So when we calculate the measures of all angles and all side lengths, if you're writing this down in your notes, solving a triangle, have this written down, that's calculating all the angles and all the lengths in a right triangle. That's solving a right triangle. Now, when we get to next year, your next math class, we'll be solving non-right triangles in a variety of ways. We'll be introducing new laws and new formulas and methods to do that, but we're going to focus on right triangles that have a 90 degree. So solving the triangle is all lengths, all sides, all angles. And of course, we can use the three primary trig ratios, which are tan. So the tan of an angle is the opposite side length divided by the adjacent, TOA. The sine is opposite divided by hypotenuse. That's the SO part of our mnemonic. And cos is adjacent over hypotenuse. So that comes from SO ca TOA. Very easy to remember. And that gives us a clue about how to use those ratios. All right. If we want to find an angle, right, like for example, angle P, okay, given the opposite, if we're given the opposite side, let's say, and we're given the adjacent side, okay, if we're given those two sides, that's OA, that's tan, so I do tan to the -1 on your calculator. And that's going to be the second function tan right here. Just as a reminder, I'm going to clip this and show you, so I can blow it up. There we go. So it's the second function, right? Tan to the -1. You'll have a second function on your tan button, and that's how you find the angle measure. Okay, right there, tan to the -1 of the ratio of opposite over adjacent. If you were given the ratio of the opposite over the hypotenuse, you would do second function what? Sine, because of SO, opposite and hypotenuse. If you were given adjacent divided by hypotenuse, you would do second function cosine to find the angle. Does that make sense? Okay. Do I need to write that down? Do I need to write that down too? I can. Let me write that down. You might want to write this down. You guys are all looking at me like I was an alien or something. You're like I had 3 heads or something. So just help yourself, okay? Let me help you, okay? So let's see. If you're trying to get P, okay, tan of P here, and you're given opposite over adjacent, you're given that ratio, then you're going to do second function tan, okay? If you're given, let's say, the opposite over hypotenuse, then to find the angle P, and I'll do this, angle P, that's proper. You know what we're dealing with there. Then we're doing second function sine. And I'll do it over here. If you're given, what's left? Adjacent over hypotenuse. If you're given that ratio or those lengths and you want to find angle P, then you use cos to the -1. Okay? All right, does that help? Is that okay?
Yes.
All right. Very important. So now we have all the tools we need to solve solve triangles. Question? Yeah?
When you use the second function, like
Yep.
does that mean you're solving for the angle?
That's right. Whenever you use the second function, you're always solving for the angle.
Okay.
Exactly. Yeah, that's right. Okay, let's try this one. Okay, here's an example from your text. Let's work through this one. So here's example 1, I think, from your text. And it says, solve the triangle XYZ. So that little triangle symbol there means triangle. Okay. If you see delta, it's the Greek letter delta as well. The Greek letter delta, it looks like just a triangle. And does anyone know what that means in science? Delta, usually delta, like, I don't know, T maybe? Do you know what this might mean in science? Anybody knows what delta means? You learned this yet? No?
Is it not for electricity or something?
Electricity? No, delta in science, when you have delta, a variable, like if T is temperature here, this means change in. And actually, when we're talking about slope, I think that I wrote this before with you guys. You've seen this before. Change in y over change in x. You seen that before? Delta? Okay, I'm getting some nods, I'm getting some shakes, I'm getting some like, I'm an alien again. So this means change in. So this is not change in though. When you have 3 letters behind the triangle sign there, that means the triangle, okay? So this is not change in this context. So context is important. All right, so we need to find the measures of all the angles and all the sides. So I know what angle y is. Angle y is 90. Okay, great. Let's do angle y is 90. Thank you. Okay, that's given. Let's do over here x, y. That side is 6 centimeters. Awesome. And y, z is 10 centimeters. Awesome. So I need to find x, z, and I need to find angle x and angle z over here. Okay. Good idea to write down what you're given and what you need to find. This would be an excellent format for you to frame your final answer. Okay? All the ones that you're given as well, write them all down. Because then it's easy for you to check too. Check to see that all the angles add up to 180. Check to see that your the lengths of your sides seem appropriate and proportional to each other. Okay? You can check them all at once. All right. So what do you want to find first? Do you want to find what do you want to find first? Angle x, angle z, or x, z? Because you have the ability to find any one of these right now. You want to do angle x? Okay. Let's do angle x down here. How am I going to get angle x? Now I'm going to go straight to angle x. I am given the opposite side and the adjacent side. So what is opposite and adjacent? Soka, toa. Oh, guess what? Tan to the negative 1 of opposite over adjacent. 6. You can go straight to this right here. You can go straight there. And so let's jump on our calculator. Try not to break it when we jump on it. We'll do second function, tan of 10 divided by 6. 59. Okay. So nearest tenth it says, so 59.0, or nearest tenth for what? Measures, all measures, okay? Nearest tenth. So angle x is 59.0. And that's going to be 59.0 what? Degrees. Awesome. Okay. All right, now you have options now. We can use another trig ratio to find angle z, but you could also do what? Sorry? The xz. Okay, no, find this, but okay, let me talk about angle z. I could use the trig ratio again, like this. It would be opposite over adjacent. Oh, I could do tan to the negative 1 again. Let's do that. Angle z is tan to the negative 1 of, let's see, from angle z, the opposite is going to be 6 over adjacent is 10. So it's not 10 over 6, it's 6 over 10. So that would be tan to the negative 1 of 6 divided by 10, or you can just put in 0.6 if you want. 30.96 or 31. 31 degrees. Okay. That's one way you could do it. What's another way not using the trig functions that you could do it? Anybody seen it now?
180 minus 90 minus 50.
Yes, you could do 180 minus 59 that we just found minus 90 that we're given. And that should give you 31 too, I think, right?
Yes.
Okay. So that's option 1. Here's option 2. So that's great. Now, what about xz? How am I going to do x? How am I going to find xz? Again, you have options here. You have options. Well, I'll just erase everything. You could do Pythagoras. You could do Pythagoras, right? A squared plus b squared equals c squared. Could you also... actually, is there another way to do it? Well, yeah, there is. You could use trig functions, again. You could take any angle. We know this angle now, 59 degrees. And let's say I wanted to use the opposite side, and I wanted to solve for the hypotenuse. Guess what? I could do opposite hypotenuse, that's so in SOHCAHTOA. I could do sine of 59 equals 10 over hypotenuse. And I know that these can just switch places, multiply by hypotenuse, divide by sine of 59. I have hypotenuse is 10 divided by sine 59, which equals, let's see, 10 divided by sine 59. 1.16, 1.7. Sorry.
You missed the,
What?
you missed
10.
The 10. You said the 10.
Oh, the 0 didn't take. Okay, good, thank you. I'm like, wait, what? Okay, let's go back and insert the 0. Hello, 0. All right, 11.7. That looks better. See, that's good. Like, I looked at this 1. I'm like, this side is not 1 unit. It's not smaller than everything else. No, it's got to be bigger. So there you go. 11.7. 11.7. So 11.7 centimeters. Okay, so what do you think? Is that what they get in the textbook there? 59. I see 31. Let's see 11.7. Okay. Awesome. So you have options in solving. Sometimes the trig is easier. Most of the times the trig will be pretty easy. All right, very good. Let's see, solve this triangle, given one angle on one side. Okay, I tell you what, I will let you look for a minute in your textbook for example 2 and their solution, and then we'll go check out some of your homework. Okay. There's the homework. So I'm going to drop that on you right now. 2.6, right? Yep. Let's make that a little bigger.